Ever feel like you're juggling like a million things at once? Like you got plates spinning.
Oh, yeah.
Now imagine your computer doing that, but on a whole other level.
Right.
Constantly managing tasks and resources and security threats, all while letting you breeze through your digital day.
Mm-hmm.
That's the magic of your operating system, or
Yeah.
OS.
Yeah.
And today, we're diving deep into its hidden depths.
It really is an intricate world beneath the surface, one that most people interact with daily, every day.
Right.
And they don't even realize the complexity of it.
Yeah.
We're going beyond the familiar icons, the windows, all that.
Right.
Guided by this fascinating excerpt from Operating System Concepts. We're going to try to understand the vital services your OS provides every millisecond.
Okay, so let's unpack this. We're talking about services, right? What kind of things fall under that umbrella?
Well, think of it this way. The OS acts as both the stage manager and the backstage crew for your digital life.
Okay.
Some services, like the user interface,
Yeah.
those directly impact your experience, while others work tirelessly behind the scenes to keep everything running smoothly.
So it's kind of like an iceberg. We see the tip, but there's this massive, intricate structure below the waterline. We rarely even think about it.
Precisely. Let's start with what you interact with directly.
Mm-hmm.
The user interface, or UI. Remember the days of clunky command line interfaces?
Vaguely.
You practically needed a computer science degree just to open a file.
Oh, yeah. I've seen pictures, all that cryptic code.
Yeah.
Thankfully, those days are mostly behind us.
Indeed, today's operating systems, they boast intuitive graphical user interfaces, GUIs, with their colorful icons.
Yeah.
User-friendly menus.
Right.
This evolution is a lot like city planning. Just as well-planned streets, clear signage, that makes navigating a city easier.
Sure.
Intuitive UIs make interacting with technology smoother and more accessible for everybody.
It's amazing how much thought goes into making technology user-friendly, I mean, we've come a long way from those command lines, that's for sure.
Yeah, for sure.
So it's not just about looks, is it?
Absolutely not.
Yeah.
Aesthetics are only part of the equation. The UI also dictates how you interact with programs.
Okay.
Which brings us to our next service.
Yeah.
Program execution.
Okay.
The OS is like the ultimate stage manager. It's deciding which program gets the spotlight, or in this case, processing power, and for how long.
So when I'm editing a photo while streaming music and checking email,
Yeah.
my OS is juggling all those programs at once, making sure they each get the resources they need.
Exactly. Without that constant orchestration by the OS, everything from editing a photo to streaming a video, it would just be a chaotic mess.
Yeah.
The OS ensures that programs load correctly, run smoothly, and even how they're shut down properly.
Right.
Or sometimes forcibly removed if
Right.
they crash.
Right.
Yeah.
Okay, that makes sense. It's all about keeping things orderly and efficient. So what else is the OS managing while we're busy, clicking and typing away?
Well, it's also playing the role of a meticulous librarian, organizing and fetching all your digital files.
Go.
Each file on your computer, from documents and photos to music, is stored within a complex file system.
So it's like having a super efficient filing system that never loses a document.
Precisely. The OS knows where every single file lives on your hard drive or SSD. That's your solid state drive. It's like a much faster, more modern type of storage.
Right.
And just like a good librarian controls access to valuable books, the OS manages file permissions, making sure that your personal data stays secure.
So we've got this amazing librarian tirelessly organizing our digital lives.
It is amazing.
But what about those behind-the-scenes services that we talked about? What is the OS working on that we don't see?
That's where things get even more fascinating.
Okay.
Imagine you're hosting a massive virtual reality game night. You've got limited processing power, that's your CPU, your central processing unit, the brain of your computer, and a set amount of memory to share amongst all of your friends who are playing.
Sounds like my kind of party, but also a logistical nightmare.
Exactly. And that's where resource allocation comes in.
Okay.
Your OS has to constantly allocate those limited resources,
Right.
CPU, memory, and even things like network bandwidth, among all the different programs running.
Wow.
It ensures that everything runs smoothly and that nothing grinds to a halt.
So it's constantly making decisions about which program gets priority. Like if I'm editing a video, it might give more resources to my editing software than, say, my web browser.
Precisely. It's like a masterful air traffic controller directing digital traffic to prevent collisions and ensure that everything runs as efficiently as possible.
Okay.
This becomes even more crucial in multi-core processors,
Right.
where multiple tasks can literally happen simultaneously.
Wow. So it's not just managing time, but also these different cores within the CPU? That's incredible.
It is. And while all this is happening, the OS is also meticulously logging everything.
Really?
Kind of like a detailed ship's log, but for your computer.
A digital paper trail of sorts.
Exactly. The OS tracks how resources are being used, which programs are running, when any errors occur.
Right.
It's incredibly valuable data, especially if you need to troubleshoot a problem or optimize performance.
Okay, so it's like having this built-in detective constantly monitoring for issues and keeping records.
Yes.
That's pretty impressive, but what about security? That feels like a whole other beast.
You're right. Security is paramount.
Yeah.
And the OS plays a critical role in keeping your data safe from those pesky malware marauders.
Because it's not just about having strong passwords, right?
Absolutely not. While strong, unique passwords are your first line of defense, a good OS employs multiple layers of security, like a fortress, with walls, guards, and even moats.
Right.
One example is a firewall,
Right.
which acts like a gatekeeper, controlling incoming and outgoing network traffic to block any suspicious connections.
Okay, so it's like having a security system that's constantly on alert, even when we're not thinking about it.
Yes.
What other security measures are built into the OS?
Well, there's sandboxing, which isolates potentially harmful programs in a secure environment where they can't access your important files or system settings.
Oh, okay.
Think of it like a digital quarantine zone.
So we've got these firewalls blocking threats and sandboxes quarantining suspicious programs. It sounds like the OS takes a multi-layered approach to security.
It does. It has to.
Right.
Think about it. Your computer stores a massive amount of personal data.
It does.
Everything from, financial information to private conversations to those embarrassing baby photos we all have.
Okay, maybe we don't need to get into the specifics of everybody's photo albums.
Right.
But you're right. The stakes are high when it comes to digital security.
Exactly. And it's not just about protecting your data from external threats.
Right.
Sometimes you need safeguards within the system itself.
You mean like when an app tries to access my microphone or camera without permission?
Precisely. A well-designed OS gives you control over those permissions.
Okay.
It's like having a digital bouncer who checks IDs at the door of your hardware.
I like that analogy. That's a good one.
Yeah.
It makes you realize how much we rely on the OS to be this invisible guardian, managing all these complex tasks without us even realizing it.
It's true. It's really quite remarkable when you think about it.
It is.
We've only scratched the surface of what operating systems do.
Right.
There's network management, input handling from your keyboard and mouse.
Wow.
All sorts of things.
It's like this intricate dance of processes happening every millisecond.
Everyone.
And most of us just take it for granted.
I think that's natural, given how seamlessly it all works most of the time.
Right.
But understanding the intricacies of how your OS functions, that can really empower you to use technology more effectively and securely.
So it's not just about being like a tech whiz.
Right.
It's about being a more informed user.
Absolutely. By understanding the why behind the what.
Okay.
You can make smarter choices about the software you use, the security measures you take, and how you interact with all your devices.
Yeah, that's a great takeaway from our deep dive into operating system services, I think.
It is.
It's about appreciating the invisible magic happening right there beneath the surface.
Beneath the surface.
And maybe even being a little inspired by the ingenuity of it all.
I think so.
So maybe next time you open a file or browse the web, you'll have this newfound appreciation for the silent symphony of processes.
Yes.
Orchestrated by your operating system.
By the OS, our digital maestro.
That's a good one.
Yeah.
Well, that is all the time we have for today's deep dive.
Okay.
Until next time, keep exploring, keep learning, and we'll catch you on the flip side.
Ever catch yourself reaching for that pinch to zoom on your laptop screen? Like some kind of tech zombie.
Happens to the best of us.
It really makes you appreciate how intuitive our phones are these days. We're diving deep into user interfaces today, peeling back the layers of how we talk to our tech.
It's fascinating, isn't it, how something we interact with so effortlessly has this whole hidden world behind it.
Absolutely. We've got a hefty operating systems textbook here, laser focused on, you guessed it, user interfaces. What's the game plan for today's deep dive?
The goal is to move past just using these interfaces and really grasp the why. Why certain designs work better, how they evolved, it's all connected.
Music to my ears. So first up, this textbook is taking us way back to the era before touchscreens, before even those colorful icons. We're talking command lines, right?
Right, the OG. Imagine having to type in a specific sequence of characters just to open a file, delete something.
Wait, seriously, Deleting a file involved a whole program running in the background.
Oh, yeah. It wasn't as simple as dragging to the trash bin.
I bet most listeners have no idea how much is happening behind the scenes, even with today's tech. So back then, how did the system even understand what those commands meant?
That's where shells come in. Think of them like translators between you and the system's language.
A digital interpreter for our digital demands. Make it make sense.
Exactly. And there were different types of shells, each with its own quirks. Kind of like choosing a language to communicate in.
So even back then, options, options, options. But if these command lines were so efficient, why the shift to the visual interfaces we're glued to now?
That's where things get interesting. Remember Xerox, PRC?
Vaguely.
Yeah.
Rings a bell. Refresh my memory.
They were pioneers in developing those early graphical interfaces, or GUIs, back in the 70s. But it was Apple, with the Macintosh in the 80s, that really brought them to the masses.
Apple, always shaking things up. So they basically swapped lines of code for something more, well, visual.
Precisely. GUIs introduced the desktop metaphor. Think Windows, icons. It made computers feel less like intimidating machines and more like a familiar workspace.
User-friendly. But hold on, before we go full-on click and drag, you said before that command lines let you talk directly to the system. That sounds pretty powerful.
It was. With a command line, you're basically speaking the system's native language, which gave a level of control and efficiency that's tough to beat.
Okay, starting to see the appeal. So why are we all command line wizards then?
Well, as you can imagine, it could get pretty complex, especially for the average user. The textbook even talks about how systems like Unix and Linux relied heavily on separate programs for different tasks.
Whoa, so even in those early systems, hidden complexity behind even simple actions. Mind-blowing.
Right, and think about it. It made sense for certain tasks, for certain users, but for most people.
Yeah, for most of us, it's those user-friendly GUIs all the way. Those icons are like our comfort zone.
And for good reason. Those early GUIs were revolutionary in making computers accessible to a much wider audience. Suddenly, you didn't need to be a programmer to navigate the digital world.
From clunky commands to sleek icons and intuitive interfaces, what a journey. Speaking of journeys, this feels like a good place to hit pause. When we come back, we'll explore the rise of touchscreens and what makes each interface unique. We're back, folks, and ready to swipe right on the fascinating world of user interfaces. Before the break, we were all about those early GUIs, those colorful windows and icons. But let's be real, today it's the era of touchscreens.
Absolutely. And it's not just a fad. The excerpt really emphasizes how touchscreens have revolutionized our relationship with technology, especially when it comes to mobile.
It's true. My phone feels like an extension of my hand at this point.
Yeah.
But a paradigm shift in design. That's a bold statement. Really? What makes touchscreens so groundbreaking?
Well, think about it. Touch is one of our most primal senses. We're hardwired to interact with the world through touch from the moment we're born.
That's true. I've never seen a baby trying to pinch to zoom on a laptop.
Exactly. Touchscreens tap into that innate human instinct, which makes them incredibly intuitive. It's fascinating, even though our smartphones have the power to run those complex command lines, the excerpt points out that they rarely do.
Yeah, I'd much rather swipe through vacation photos than type out code on that tiny keyboard. But with all these different interfaces out there, it does make you wonder, is there a best one?
That's the thing. There isn't a single answer. It all depends on the user and their needs.
Fair enough. We all have different comfort levels with tech.
Exactly. The text even mentions how tech-savvy users, like system administrators, often prefer those efficient command line interfaces. They can zip through tasks with lightning speed.
They're like the code whisperers. But for us mere mortals, those visual cues and intuitive layouts of GUIs are a lifesaver.
Absolutely. GUIs make navigating complex systems feel almost effortless. But, touchscreens, while intuitive, they bring their own design challenges to the table.
Oh, I bet. Trying to fit all those icons and menus onto a tiny screen can't be easy.
It's more than just downsizing things. The real challenge, and what makes touchscreens so interesting from a design perspective, is that they've driven the development of completely new ways of interacting.
So it's not just about adapting desktop elements for a smaller screen.
Nope. Touchscreens brought about a whole new language of interaction. Think about those gestures, the pinch to zoom, the swipe to navigate. Those feel so natural on a touchscreen, but try doing them with a mouse and keyboard.
People would think I'm doing some weird interpretive dance at my desk.
Exactly, and this shift towards a more gesture-based way of interacting, it really highlights how technology is always evolving to bridge that gap between our physical and digital experiences.
It's mind-blowing to think We've gone from painstakingly typing out commands to tapping away on glass, and it all just works. But what's next? Are we going full-on sci-fi, just thinking at our devices to make them work?
Well, we're not quite there yet, but the excerpt does hint at some exciting possibilities down the line. Remember how we talked about different ways of communicating with these interfaces? Command lines were like speaking the system's language, GUIs were a visual translation, and then touchscreens brought us closer to that natural physical interaction.
Right. So what's the next step? How do you make that interaction even more natural?
Imagine interfaces that respond to our voices flawlessly, to gestures in 3 dimensions, even to our emotions. We see glimpses of it already, those voice assistants, the advanced gesture recognition.
True. I can already ask my phone for a weather report, set reminders. But it does sometimes feel like I'm talking to a very literal-minded robot.
Exactly. It's still early days for these technologies, but picture a future where using tech feels as natural as, well, talking to another person or just moving through the world.
Okay, now that is seriously cool. From those rigid command lines to potentially just thinking, and it happens. User interfaces have come a long way.
They really have. And for your listeners, the takeaway here is it's not just about what these devices can do, but understanding the how, the mechanics behind it all. That's what gives us more control over our digital experiences.
So the more we know about how it all works, the more power we have as users. I like the sound of that.
Exactly. And who knows what amazing developments are still to come. But one thing's for sure, the evolution of user interfaces is far from over.
And on that note, we've reached the end of our deep dive into the fascinating world of user interfaces. We've gone from those early command lines to today's sleek touch screens, even had a peek into the future. It's incredible how much complexity and innovation goes into something we use every single day.
It really goes to show there's always more than meets the eye when it comes to the tech we interact with.
Thanks for joining us, everyone. Until next time, keep those digital curiosities alive. You never know what you might discover.
All right, ready to dive deep. Today, we're going to unlock a mystery. One that happens every single time you use your computer.
Oh, I like mysteries. What is it this time?
We're diving into the hidden world of operating systems and something called system calls. Ever heard of them?
System calls. Definitely. They're how things get done, really.
You know, like when you drag and drop a file? Seems simple, but...
Oh, behind the scenes. It's a whole symphony of activity, all thanks to those system calls.
A symphony. Okay, you got to break that down for me. What are they, really, and why should I even care?
Right. So every time you tell your computer to do anything, even something basic, it needs a way to talk to the operating system, right?
Makes sense. The operating system, it's like the software running the whole show.
Exactly. Like the conductor. And system calls. They're the language your apps use to talk to that conductor, the OS kernel, the core, you know.
So the system calls like the bridge between me saying, open this file, and the computer actually doing it.
Perfect analogy.
Yeah.
Think of it like you're at a restaurant, right?
Okay, I like where this is going.
You wouldn't go back to the kitchen and tell the chef how to make your meal, would you?
Definitely not. I'd probably get kicked out.
Exactly. You tell your waiter, the waiter tells the kitchen, food appears like magic. System calls are those orders going to the kitchen.
Okay, I'm following. So the waiter's like the .api. I always hear that term, but...
You got it. API, it's like the menu for programmers. They don't have to write code for every tiny thing on every different system out there.
So I can open a file on my Mac the same way I do on, say, a Windows machine without needing a whole new set of instructions.
Boom. That's the API doing its magic. Like a universal adapter, smoothing out all the differences.
But how does the system call actually work? Is it like smoke signals from my laptop to the motherboard? Not quite smoke signals, but IS kind of like sending coded messages. Way lower level than you'd think, though.
Way lower. Like imagine the difference between writing a letter and sending Morse code.
Oh, okay. Getting a bit more intense.
Right. Every system call, it's your computer flipping a bunch of switches, ones and zeros, telling the OS kernel exactly what to do.
And this is happening constantly. With every click, every keystroke, my brain's melting a little.
It happens all the time. It's mind-boggling how much is going on under the hood. But there are systems to manage it all, of course.
Systems within systems? Like, give me a peek behind this curtain.
So one key player is the runtime environment, or RTE for short.
The RTE, that sounds important. Is that like the air traffic control for all these system calls?
Perfect analogy.
Yeah.
It's the intermediary, right, between those high-level APIs we talked about.
Which are like the menus for programmers, right?
Exactly. The RTE bridges that gap to the super low-level system calls the OS understands, translates, manages resources, keeps things running smooth.
So it's like a specialized translator making sure those crucial conversations happen.
Precisely. Without the RTE, it'd be chaos. Imagine trying to run a restaurant where the diners speak a dozen different languages and the kitchen only understands, like, ancient Sumerian. Yeah, that's a recipe for disaster.
Yeah.
Okay, so we've got these system calls, they're talking to the OS, the RTE's managing everything. But if it's all about programs in the operating system, why are there different types of system calls? See, in my head, it was like they're all about files, right? Opening, saving, that kind of thing.
See, that's the thing. It's way broader than that. We're talking practically every interaction between your software and the OS.
Okay, now my curiosity is really piqued.
It's true. The text breaks them down into 6 main categories. Each one is vital to keeping your computer humming along.
Okay, so not just files. What else are these system calls up to? Spill the beans.
All right, so one category is process control. Think of it like the operating system's the conductor, right? And each program you run is a musician in the orchestra.
I like that analogy. So system calls like fork, exit, these are the conductor's cues. Creating new processes, ending others, making sure the whole thing doesn't fall apart.
So it's like system calls are directing the flow of all these different programs, making sure they play in tune.
Exactly. Then we got file management, which, yeah, it's about your documents and all, but it's bigger than that.
Bigger how?
It's how programs access, modify, store data on your hard drive, SSD, whatever you've got. Without it, your computer would be like a library with no Dewey Decimal System. Total chaos.
My worst nightmare. Okay,
Yeah.
What else we got? Lay it on me.
Device management. This is how programs talk to all the physical stuff. Printers, scanners, webcam, even your network connection. All need system calls to function.
So like my printer only understands system calls, not me yelling at it to print faster.
Pretty much. It's the universal language for all those devices. Then there's information maintenance. The OS is constantly keeping tabs, right? Battery life, memory, even the temperature.
Oh, right. So my laptop doesn't burst into flames. Important job.
Exactly. Programs use system calls to get that info from the OS. Then there's communication and protection.
Ooh, those sound juicy. Communication how?
This is how different programs talk to each other. Imagine one's playing music, the other's showing the lyrics. They got to sync up somehow, right? System calls.
No more out-of-sync karaoke sessions.
Gotcha.
And protection. That sounds like a big one these days.
Huge. This is what enforces the rules. What each program can access, what it can't. Stops malware from messing with your system.
The system calls, they're like the digital bouncers at the club.
Best analogy yet. And what blows my mind, these same concepts, they apply whether it's a tiny Arduino.
Those little project boards.
Yep. Or a massive server running FreeBSD handling like millions of users. Same system call principles at work.
It's amazing how fundamental these things are. I started thinking system calls were just some boring tech detail.
Oh, they're far from boring.
Now I see they're like the unsung heroes holding the entire digital world together.
Totally. And the more we rely on tech, the more crucial it is to understand this stuff.
Couldn't agree more. So, listeners, if you're curious, go do some digging. Find out what system calls your operating system uses. It's fascinating, I promise.
You might be surprised what you uncover.
And as always, thanks for joining us for another deep dive. Until next time, keep exploring. Welcome, everybody. Ready to go deep. Today, we're diving into the hidden world of system services. You know, like all the behind-the-scenes stuff that makes our digital lives actually work.
Yeah, it's a bit like we're peeking under the hood of a car. You hit the gas pedal and it just goes right.
Yeah.
But there's a whole lot of engineering making that happen.
Totally. But instead of gears and pistons, we're talking algorithms and processes. I'm excited to break it down. So, like, what exactly are system services? I mean, I've never actually seen one.
They're like the unsung heroes of the digital world. Think of them as specialized programs that kind of translate your commands into actions the computer understands.
Okay, so when I hit save, it's not magic. There's actual, like, code doing stuff.
You got it. Hitting save sets off a whole chain reaction orchestrated by these services. They handle finding space on your drive, making sure the data is written correctly, the whole shebang.
Wow. It's kind of mind-blowing how much is happening behind the scenes without us even realizing it.
Right. And one of the coolest examples of that is the network daemon. Ever wonder how your computer just, like, knows how to connect to the internet?
It's like magic, right?
Not magic, network daemon. It's constantly working, managing those connections so you can browse, stream, email, all that jazz. without a hitch.
Okay, that's the one I don't want to live without. Streaming is life. But tell me more about this daemon. It sounds kind of shady.
Uh-huh. The name sounds kind of ominous, right? But it's actually your best bud when it comes to the internet. It handles all the complicated protocols and data packets flying around behind the scenes, making sure everything flows smoothly.
So like a digital air traffic controller, making sure all the information gets where it needs to go.
Exactly. And speaking of air traffic controllers, we got to talk about the process scheduler, another unsung hero. This will make sure your computer doesn't completely freak out when you've got a million things open at once.
Okay, yeah, I'm definitely guilty of having way too many tabs open. How does it even handle that?
So you got all these programs, right? Browser, music, games, whatever. They're all fighting for the same resources, like processing power and memory.
Right, like a digital Hunger Games.
Yeah, kind of. And the process scheduler is like the referee. It allocates those resources fairly, makes sure no single program hogs everything and crashes the system.
That's pretty crucial. My computer crashing is like my worst nightmare.
It's essential for a smooth user experience. And these are just two examples, right? There are tons of other system services working tirelessly behind the scenes. It's amazing what's going on in there.
Yeah, it's like a whole hidden world just humming along, keeping our digital lives running. It really is. Makes you appreciate what's going on beneath the surface, you know?
Fully. And it's not just about keeping things from crashing. These system services, they're also working hard to make our devices more efficient.
Right, like battery life. That's always a big deal.
Exactly. There are system services dedicated to squeezing every last drop out of your battery. They monitor how much power you've got left, how bright your screen is, even how fast the processor's running.
Wow, so they're like little power managers constantly making adjustments?
Yep, all in the name of keeping you going for longer. It's pretty impressive, actually.
Okay, but how does all of this actually affect me? I mean, I don't directly interact with these services, right?
That's where things get really interesting. See, these system services, they're like the foundation. They provide the raw capabilities that developers then use to build the apps and interfaces we see and use.
So it's like they provide the ingredients, and then the developers, they're the chefs who turn them into a tasty meal.
Perfect analogy. Take the file system, for example. It doesn't care if you're writing a book or composing music or just making a shopping list. It just provides the space to store that information and ways to organize it.
And then it's up to the app, like the word processor or the music software, to actually make that information usable to us, right?
Exactly. And the cool thing is, the same underlying system services can power totally different experiences.
Oh, I see. So two phones, same operating system, but they could feel completely different based on the apps they have and how those apps are designed, right?
You got it. It's like having the same set of Lego blocks. You can build a castle, a spaceship, whatever you want, depending on how creative you are. And that's why it's so cool to understand these underlying system services.
Totally. It's like being able to appreciate not just the finished product, but all the work that went into making it. So we've got these hidden heroes, keeping things running, making things efficient, but also shaping our digital experiences in ways we don't always realize.
And here's the thing. This relationship between system services, apps, and users, it's constantly evolving, especially as technology changes.
Totally. Like with AI becoming such a big deal, what do you think the future holds for system services in an AI-powered world?
Yeah.
It's like, are our phones going to start finishing our sentences for us? But on a deeper level.
It's wild, right? As AI gets more powerful, those system services, they're going to need to keep up. Imagine your device not just running AI, but actually learning from it,
Okay, so instead of just managing files and connections, they're going to be managing, algorithms.
Exactly. We're talking about handling massive amounts of data, making sure those AI processes have the resources they need, all without your phone bursting into flames.
Okay, that's a visual. But seriously, that's a lot of responsibility.
It is. And it's only going to get more complex as AI develops. But think of the possibilities. Imagine a system that literally anticipates your needs.
Okay, it knows I'm going to need to order a pizza on Friday night, and it's already prepped the app.
Maybe. But on a more practical level, it could optimize your phone's performance throughout the day based on what it knows you're going to be doing. It could preload your go-to apps in the morning or free up memory when you're about to game.
Wow, that's next level stuff. It's kind of mind-blowing to think how much potential there is.
It really is. We're just scratching the surface with AI. Who knows what kind of amazing system services we'll have in the future.
Well, I gotta say, this deep dive has definitely given me a new appreciation for all the behind-the-scenes action happening on my devices.
Right. It's like we've uncovered this whole hidden world, working tirelessly to keep our digital lives running smoothly.
Exactly. So next time you're scrolling through your phone or watching a video, take a second to think about all those system services, the unsung heroes of the digital age.
Couldn't have said it better myself.
And on that note, we'll wrap up this deep dive. Hope you enjoyed exploring the fascinating world of system services with us. Until next time.
Okay, let's dive in. Today, we're going behind the scenes of something we use every day but rarely think about: operating systems.
The silent partners in our digital lives.
Exactly. We're talking about what makes your computer actually tick. Not just Windows or Mac OS, but the fundamental software that makes any Y computer usable.
Right, it's the unsung hero, the maestro behind the scenes.
I like that, the maestro.
Yeah.
And our deep dive today is based on an excerpt from an operating systems textbook you provided. It talks about the OS as a resource manager, which, honestly, when I first read it, didn't exactly scream fascinating. So what does that actually mean? What's being managed?
Well, think of it this way. Your computer has all these vital resources: the CPU, memory, storage, and all those input-output devices. The OS is like the conductor, making sure they all work together in harmony.
Okay, I'm starting to see the maestro analogy coming to life here. But how does it actually DO that? Like, what's an example of a resource that the OS is constantly juggling?
Well, take CPU time, for example. The CPU is the brain of the computer, but it can only do one thing at a time really, really fast.
Right, like the super speedy calculator that can only handle one equation at once.
Exactly. So imagine you're browsing the web, listening to music, and editing a document all at the same time.
Wait, you mean to tell me that's not all happening simultaneously?
Not in the strictest sense. Each of those actions is a process, and the OS has to decide which process gets to use the CPU at any given moment.
So it's like a time-slicing ninja, making sure everything gets a little bit of the CPU's attention.
Exactly. That's called scheduling. And it also has to make sure that those processes aren't interfering with each other. That's synchronization.
Okay, I'm definitely getting a new appreciation for what seems like a simple click of the mouse. But it's not just the CPU that the OS is managing, right? The excerpt also mentions memory management. And I feel like there's more to it than just how much RAM you have.
Oh, absolutely. RAM is just one piece of the puzzle. It's the super fast short-term memory where active programs and data hang out. But there's a whole hierarchy of storage that the OS has to manage, from those super fast registers to the hard drive.
So it's like RAM is the express lane, but there's a whole system of back roads and side streets that the OS is navigating to keep things moving.
That's a great way to put it. And to make things even more interesting, it's not a one-way street. The OS is constantly moving information between these different levels of storage to optimize performance.
Wow. So even just opening a file is a more complex operation than I realized. And we're back, diving deeper into the world of operating systems. Before the break, we were talking about how the OS manages resources like a pro. But let's be honest, when we think about using a computer every day, it's all about those files and folders.
Absolutely. It's how we organize our digital lives.
Right. But the excerpt we're looking at today says the OS manages mass storage. So it's not just about those neat little icons on our desktops.
Not quite. Those icons are just the tip of the iceberg. The OS is dealing with the raw data on your hard drive, translating it into something we can actually understand.
Okay, so it's like a digital interpreter. What would it look like if we didn't have that translation layer?
Imagine trying to find a single photo on your computer, but instead of browsing folders, you're faced with pages and pages of raw binary code.
Yeah, I think I'd rather just stick with my photo albums in that case.
Exactly. The OS creates this illusion of files and folders to make our lives easier. It's called abstraction, hiding the complex stuff behind a user-friendly interface.
Okay, so abstraction is our friend. But with all that data flying around, how does the OS make sure things run smoothly? I mean, it's not like my computer's constantly crashing because it can't find my files.
That's where caching comes in, something our excerpt touches upon. It's like having a mental shortcut for frequently used information.
So instead of searching my entire house for my keys, I just kind of know where they are because I always keep them in the same spot.
Exactly. Your OS does the same thing with frequently used files and programs. It stores them in a special place called a cache, so it can access them faster next time you need them.
So that's why some websites load so much faster on the second visit. It's like the browser remembers where it stored the information.
Precisely. And it's not just websites. Caching is used everywhere in computing, from loading apps on your phone to rendering complex graphics in video games.
Caching, you are the real MVP of a smooth digital experience. We've talked about resource management, file systems, and this whole caching magic.
Yeah.
But there's one more big piece of the OS puzzle we haven't even touched on: input and output.
Ah, yes, the I/O subsystem.
It sounds kind of intimidating, to be honest. What's going on in that corner of the OS world? Back again. We're in the final stretch of our deep dive into operating systems.
And I have to say, it's been quite a journey.
It really has. We've gone from thinking about the OS as just like the thing that lets me open a Word doc.
Right, that kind of invisible force in the background.
Exactly, to really appreciating how much complexity is going on behind the scenes every time we interact with our computers.
It's like we've been given backstage passes to the most amazing show, but instead of actors, it's algorithms and data structures.
Love that analogy.
Right.
So before we wrap things up, what would you say are the biggest takeaways, the aha moments for you from this deep dive?
For me, it's the sheer ingenuity of it all. The way these systems have evolved to handle increasingly complex tasks, managing resources, creating these abstractions that make our digital lives possible. It's really quite elegant.
It really is. I mean, we take it for granted, but the OS is the reason we can do everything from sending emails to editing videos to streaming our favorite shows. It's the foundation for it all.
Absolutely. But you know, this excerpt we explored, it's just a snapshot of operating systems as they are now, and the tech world moves fast. What about the future? Any predictions?
Ooh, good question. I mean, we're already seeing this shift towards cloud computing, the Internet of Things, devices becoming more interconnected.
Right, and that's going to require some serious innovation in operating system design. Think about it. How do you manage resources effectively across a network when the data and processing power might not even be on your own device?
That is a huge GE question. It's like the OS is going from being the conductor of an orchestra to, I don't know, coordinating a global symphony.
Exactly. And it's not just about scale. Security, privacy, reliability, these become even more crucial when we're talking about a distributed system.
Wow. So to our listeners out there, the next time your computer does something amazing, or even just opens a file without crashing, take a moment to appreciate the unsung hero working behind the scenes, the operating system. And who knows, maybe someday you'll be the one designing the OS of the future. That's all the time we have for today's deep dive, but the conversation doesn't have to end here. Keep exploring, keep questioning, and as always, keep diving deep.